Okay, it's 10:01, so I think we'll begin. Welcome everybody to the Endress Hauser Digitalization Seminar, our process user group meeting this month. This event is being recorded, so if you would please keep your phones on mute, it would be appreciated. Any questions you have, you can type into the chat window. Or if you wait to the end of the session, you can take yourself off of mute and ask them directly. With that said, I'm going to let Jason get started. I have Jason Engel from Endress Hauser doing the presentation today, and with him is Jeff Canizo, our local Endress Hauser representative. Take her away, right. Jason.
Thank you, Steve. So my name is Jason Engel. I'm the Director for Business Development within our Digital Transformation Solutions team. I'm out of Philadelphia. I'm actually down in Houston this week, but from the Philadelphia area. So Steve's asked me to give a bit of an overview of sort of the migration that Endress Hauser is having into the digital world, and have some slides up. If you guys can just say yes, these are showing, I'll get it started.
Yeah, you're good.
Okay, awesome. Okay, so the digital migration with Endress Hauser. Okay, so just a little bit of sort of context or historical here. Looking at the architecture when you have PlantPAX as your DCS, and just giving you a visual from, if I look at the bottom and the field devices that Endress Hauser has, or valves or drives, how those field devices historically have plugged into a DCS, ultimately going to the top here, the control room where the engineers, where the operators might sit to manage and run the process for a facility. So just a historical view of how an architecture is laid out for a DCS going all the way down to field devices. Also, a bit more context. We are at HART 7, just in sort of the series and the progression of HART. And just to share with you where 5 was, then 6, it brings us into the digital side, and now that we're at HART 7, it can do full digital communication. It's not always realized, but the capability is there. If you think about the progression of HART, sort of in parallel is also that progression for industry. So with Industry 1.0, we are now at Industry 4.0. One could say the Industry 3.0 is the use of robots. Industry 4.0 now takes us into that digital area. And a piece that we're all trying to better understand and better leverage within the digital arena is the data that's coming out, and how can we use the data to proactively manage, to predict what might happen, so we're not necessarily running to failure. We are running and optimizing that process or those processes. So just giving you a bit of the history side to help with the discussion. So as we move forward a bit more, Ethernet IP is one of the digital communication pieces or protocols that are out there. And just to give you a view, this looks a little bit different than the architecture or the topography on that first slide, but just to draw some attention, on the right-hand side with field devices, on how they can be wired, and at the bottom there with drives, and then on the left-hand side with 2-wire devices and how they can be wired, and it all goes into the device level ring for Ethernet IP. So just continuing to show some of the progression from just HART communication into Ethernet IP, which takes us into the digital the digital world, more into the digital world. Oh, there we go. And just illustrating it a little bit more with the animation that's there. So to share a bit about what's the difference between analog communication and digital communication. A simple way to state that difference is analog is one-way communication, digital is two-way communication. And so you can send back the data, but you can also move forward with commands or changes or whatever that second line of communication can be. So in a simplistic manner, one-way versus two-way communication for analog to digital. And why that's important. So if I take a magnetic flow meter in the analog world, you'll get the flow output. So that's a 4 to 20 milliamp that's scalable to 0 to 100 gallons or whatever you might have that flow calibrated in. But to compare that to the digital side, we can get so much more process values out of that digital piece, where you can get flow, conductivity, a totalizer, you can have device diagnostics, you can do the remote configuration, all of which are part of that two-way communication. And you can see the value of the device significantly grows in the digital side because there's so much more information that can be taken out of the field device of the unit to further bring value for it. So, oops. Okay. So if we look at the Endress Hauser offering, not all of our devices, most of our devices are digital, but not 100% of them have something that's called Heartbeat. Heartbeat is one of those diagnostic platforms that allows us to proactively measure, proactively control the instrumentation. And so just to give you a visual of those devices that do have this digital heartbeat communication or heartbeat technology within flow, within level, within temperature, within analytical or analysis, and then also in other. For us, other is like that's a gamma level on the right-hand side with the long silver tube. So though I think 95% of our devices are digital, a smaller percentage have this heartbeat technology, which assists with diagnostics in the digital world. And to share with you why the digital piece is important, we use NAMUR 107, and those are 5 different diagnostic protocols that assist a facility, assist a control room to run their plant. And it allows them to actually sort of see into the unit on, are we running okay? Is maintenance required? Are we failing? And the colored symbols illustrate that in a very visual way. So if you get a maintenance is required, you have the blue oil can actually shows up on the display of the unit, shows up within the DCS, the maintenance is required. If the unit has failed, you have the red box. If you need to check the function, maybe it's out of calibration, you'll have the orange wrench. And if it's out of specification, you have the yellow question mark almost inside the yield sign. So part of why the digital communication, it enables the heartbeat technology, which again allows the customer to use the NAMUR NE107 and its 4 different diagnostic categories. So to help illustrate a bit more of what this heartbeat is, looking at a flow meter and seeing how we could potentially get this is just a picture of, you might get a blue oil can of maintenance is required when you begin to have buildup within the flow tube, as you see in the picture there. And if it continues to build up even further, this is an example of where you might get the X for it is failing, and you see how much buildup is inside that pipe. And so these different colored visuals help the customer to ideally proactively manage the running of their instrumentation, so it doesn't just run to failure. Because when a line goes down, potentially, depending on what's being manufactured, it could be $1 million a day of lost revenue. And obviously that can add up very, very quickly. So the first slide I shared with you was a traditional HART topography. And a view I want to show you now is how we can begin to further digitize it through what's called an edge device. So the visual that just popped up in the right-hand corner, the edge computing device, I'd like to equate this to, as you're all sitting here with your cell phone. Your cell phone doesn't work unless it connects to a cell tower, a mile away, 5 miles away. We see them as we drive around every single day. The edge computing device is very similar to a cell tower. It allows, or it enables, the communication to go to the cloud. So the radars, for the radar level transmitters that are in the bottom right-hand corner, obviously they will continue to travel up into the DCS for control. But if you can add an edge device, it can then send the readings and the data into the cloud, which again potentially enables us to look at the analytical pieces, to look at the data, to see how we can learn from the data. And Endress Hauser's cloud is called Netilion. To show and sort of illustrate this in a little bit of a different way for you, the current view, it's a SCADA system that has a 420 connection to a pressure transmitter in the field. You have HART as your communication. We step it up one more level and put a Modbus TCP. So it's just showing again the progression of the communication to the field devices. And we do one more. We have a radar level with a wireless HART that goes to a wireless gateway. And if we go one more, we have now instrumentation. So that's a level transmitter with an LTE card. So that a card just like you'd have in your cell phone that goes to the cell tower, there's now a radar level transmitter with its own LTE card that can go to an LTE receiver, which is what that visual is. And so just sort of a summary of that migration and the pieces that are popping up on the left. This is traditionally what you would see in your control room. And again, how that version can be upgraded to become digital. So if I'm looking across the top, it's your traditional 4-20 HART, which runs into the localized plant management, plant asset management. But if you can add a edge device, which is the VPN router, which is the internet connection, it allows that data to go digital. But if I jump down to the wireless HART application and you run across the screen there, that wireless HART, which goes to a gateway, which is the little box with the antenna, that gateway can go directly to the cloud. So you're just digitizing the data. And ultimately, adding the edge devices, which are in the middle there, it brings the data into the cloud. It brings the data into Netilion, and then you can use apps that Endress Hauser has on the App Store that you can download so that you can view the value of that radar that's measuring, level in a tank, you can look at your value app on your phone and see the level of that tank as you're looking at your telephone, or you're looking at an iPad, or you're looking at, whatever kind of device. And that's what I want to share with you in the next couple of slides are what are the different tools, the different services within Netilion. Once you can get that data into the cloud, what does that mean and how can that assist and benefit? Pause for just a minute here. Any questions or comments as I've shared sort of a progression of the HART 420 into a digital digital architecture? Any comments or questions? Okay. Are you guys still there? Can you give me just a voice check?
Yep, we're here.
Okay, thank you much. So to share a bit more then with the different platforms within Netilion. So first is the platform called Analytics. And one example of the analytics dashboard is looking at the right-hand side for asset obsolescence. So if you have a facility with 257 tags or 257 field devices, this is a view of what is currently available and what is working to be phased out. So just a very simple visual showing obsolescence. Another a way to view it is the screen in the middle within the DuraBook, which is just an explosion-proof tablet of showing all of the assets that might be uploaded and linked into the Netilion cloud. And this can show not only Endress Hauser instrument tags, but it can show our competition. It can show a valve. It's not communicating and controlling the valve. It's just showing what the data is. So this is just a couple of the views that the Netilion Analytics app can show to you. Another feature within Netilion is what's called Library. And Library can also be called digital documentation. Thinking about a large capital project, they work with an engineering firm. That engineering firm provides 8 3-ring binders to the customer at the end of the project. Here's all your documentation. And routinely, those 8 3-ring binders get put into a closet that unfortunately someone might not even be able to find a week later. So with the ability to digitize all of that data, one can then pull up the library, or they can pull it up on their iPhone, on their Android, which is the picture on the right-hand side, and by tag number, they can literally search and digitally view, the original calibration certificates, the original commissioning data, the spec sheet, all of the data that went along with the instrument from its original engineering design, procurement, and startup. So the library feature literally is a tool for digital documentation to make it very easy to find those pieces of data. 12 months, 2 years, 10 years after they've been startup and commissioning. The next tool or platform within Netilion is Health. And if you recognize the NAMUR 107 symbols, that's exactly what the Health app is working to show you in a very simplistic way. If I look at the phone on the right-hand side, you have 134 field devices that are running well. You have 2 that are failed. You have 1 that requires maintenance, which is the blue block that's highlighted. You have 3 that might be out of specification. And then you have 2 that just need they need maintenance. That's the blue, that's the oil can. So again, working to show you to ideally move to be able to run the facility in a proactive manner versus run to failure. This is what the Health app can assist to illustrate. Another one of the apps that's in there is the value, and simply stated, it's viewing the level, it's viewing the flow straight out of the device. You get a real-time value for a real-time reading for what that value is, and the view itself within the app can be configured. It can be shown on a table. It can be shown on a map, because you have 3 different tank farms across upstate New York. You can have a view of them all within the value piece. And the view within value can be customized to fit a customer's needs. There's some insight that needs to be there, but that's why there's a couple different ways that this is illustrated here on the phones. And I will share more with you in the next slide. But one last piece is called the Scanner app, and the view on the right-hand side is what the Scanner app would look like when you would turn it on. But what's unique, what's great about this platform is you have a phone, you have a tablet, and you're taking a picture of the device as it is installed. And you can add an RFID tag to it. You can add GPS to it. But you then have a live picture of said device, and it can be a valve, it can be gas detection, it can be a drive, but you have a picture of it installed in the field, so they can easily say, I know where that transmitter is. It's next to the green pole and in front of the water tank. That you can take pictures of it just to document where things are in the facility, and then you can tag all the additional points of data to it. So a very, very flexible app with this scanner tool. So to share with you sort of an application of how one of these show you an example of how these applications can be used. So what I have up on the screen here, this is a battery powered radar level transmitter with a LTE card, so the radar transmitter can transmit directly to the cloud. So that's the visual that I'm sharing with you there. And some of the other devices that we have that can do similar, just shows this is an analytical on the left-hand side, another radar level, another analytical, and a temperature transmitter. So just some of the technology that we're beginning to introduce to the market that also has these LTE wireless cards. And this is just another visual of what the gateway could look like if you communicate with Bluetooth, which is the box with the black antenna. And then on the left-hand side, what a edge device is. And as I was explaining earlier, the edge device is similar to your cell tower that connects your telephone to the world. So an example for you, this radar level transmitter, for us, it's an FWR30. It's a wireless battery powered level transmitter that customers have been just putting on top of a tote. So they have a live reading of what's in that tote. And you can see the device here sitting right on top of the tote in the top left-hand picture. On the bottom right, again, just another positioning, but the device sits right on top of the tote, knowing that a tote will have a fork truck come over to drive it away. It's battery powered. It just sits there and reads the level. And then you can customize that value dashboard to show the different tanks. And obviously there's a little bit of sort of math to figure out the volume and where the level lies. But this is an example of a Netilion ready, an IIoT ready level transmitter that can provide data directly to the Netilion cloud, which then can provide data through an app to your phone. So no longer does it need to go through the DCS. It's just for monitoring. It's not for control, but the ease of use is part of the driver that of why this was created like this. We frequently get the question about security, and we understand the security of the information is important. The security of the cloud is very important, and ultimately, it's the product that is being made, the product that is in the field there, monitoring, working with, in the middle of the process. So the Netilion Cloud or the Endress Hauser IIoT platform has a 4-star rating from Eurocloud, which is a European regulatory commission for IoT. That Endress Hauser is a Swiss-German company. We've achieved the highest level of security from Eurocloud, and we also work within compliance, the ISO 27001, which is a information security certification through ISO. So there's definitely been a significant amount of security built into the platform. And then one more piece for you. If you hear the term API, that API can be explained as that's the sort of the information highway that takes the data from the field up to the LTE cloud, up to the LTE wireless communicator, which sends it to Netilion, which sends it to the cloud. The API is just what's translating the data from the cloud to your then computer. And an example for you here, if you're looking at the weather app on your phone, there's API that's constantly going into the weather app to tell you what the weather is today or later today or tomorrow. And it's just the highway of information, and the Netilion cloud can go, directly into a CMMS, or it can go directly into a BASF cloud, a customer cloud, what have you. It's just the highway for information, which is very programmable and very customized. But that's just a quick explanation of what the API is. So this is a brief overview of how Endress Hauser is migrating more and more into the digital world. About greater than 90% of our portfolio is already digital, but it still is wired and set up with the traditional 4 to 20 HART. So most of our 90% of our devices can provide so much more value to the customer if they're set up in a digital way. So it is an exciting piece that is out there. We're continuously talking with our customers to try to get them to bridge into more of a digital world, because there is a lot more value that can come out of the devices. It's a challenge that is ahead of all of us. So these are the slides that I have for you, providing this overview. And please, any questions or comments are welcome at this time.
Do we have any questions for Jason? You can now take your phones off of mute and ask him directly.
Yeah, Jason, I have a question.
Yes.
Can you go back to that last architecture drawing? It was kind of where you were showing the 4 to 20 loop powered devices. Let's see.
This one?
Yeah. I mean, you explained this a couple times. I just want to make sure I understand it. Like you said, a lot of customers already have 4 to 20 milliamp loop powered devices. So,
yes.
That could get them this heartbeat diagnostics digital information already. So they don't necessarily have to add any more equipment. unless they want to get it up to the cloud.
Correct. The cloud just enables that information a bit more. It enables further flexibility. It enables, hopefully, it enables additional value that can be seen from the data. So that's the added component with going to the cloud. Yes, Heartbeat doesn't have to go into the cloud to work, but it makes it easier. It makes the data easier. It makes it more accessible. These days, I have to print out the PDF. That's one more piece of paper or data that can get misplaced or lost or not found during a critical maintenance shutdown. So a lot of the ease of business, if we can keep all of those components digital, it's easier to find during a time of need.
Okay, thank you.
Yep.
Hey, Jason, it's Jeff. I guess as maybe even a follow-on to that question, I mean, out there today exists, lots of instruments connected to PLCs and/or DCS systems. Is there a way to get that information from at least those instruments into the cloud? Was that this edge that you're talking about?
Yes.
This edge?
Yes.
Okay.
That is exactly correct.
So that's just something that would be added to the PLC system?
It would be added into the cabinet, and as you can see of the slide that I have up, where the edge device can be added into all of the different setups.
Okay.
From 4 to 20 HART all the way down to an Ethernet IP. So you're adding an edge device into the cabinet, allows the data in one-way communication to send the data to the cloud, which also accomplishes the security requirement. So you're not sending signals into the DCS that would disrupt anything, but it provides the data, allowing the data to go out to then easily configure into an app of some sort to provide additional value.
Okay, and to get multi-parameter type information from an instrument, we'd have to have at least HART going into a HART input card of some sort, right?
Yes.
Okay.
Yeah, because that's still the control signal through the DCS is
Right.
through HART or through Ethernet IP or through whatever that communication protocol is. Yep.
Okay. All right, thanks.
Well, it sounds like we may be done, Jason. So again, thank you all. And with that, we will conclude.